11.3 is about probability of multiple events. So again, the key here is wording of things, and or the word or. If A and B are independent events, then probability of A and B, what we want to do is multiply them. The key here is independent events. If A and B are mutually exclusive events, or means to add them. But what I would look at here is the A or B is probability of A plus probability of B minus the probability of A and B. The mutually exclusive thing means that one can happen, the other can't. That's why you don't have to subtract it. But I would always think about subtracting first. So example 1, are the outcomes of each trial dependent or independent events? Roll a number cube, then spin a spinner. Well, does one affect the other? And the answer to that would be no. So these would be independent events. What about B? Pick one flashcard, then another from a stack of 30 flashcards. Now, that's not a great example because they don't really tell you what you do with the other card. And because they don't say that you put the card back, we're going to assume you don't. So your probability changes your second card because you didn't put that first card back in. So these are what we would call dependent events. Example 2, at a picnic, there are 10 diet drinks and 5 regular drinks. There are also 8 bags of fat-free chips and 12 bags of regular chips. If you grab chips and a drink without looking, what's the probability that you get diet drink and fat-free chips? So the key word here is and, so I'm going to multiply. Well, how many diet drinks are there? There are 10 diet drinks out of how many total? Well, it's 10 diet, 5 regular, so 15 total. Times fat-free chips, there's 8 of those, and 12 regular, so it's 8 out of 20. Multiply them together, and you end up with, when you reduce 4 over 15, which is about 26.7%. Example 3, you roll a standard number cube. Are the events mutually exclusive? So you're just talking about rolling it one time. So you can roll a 2 and a 3. Well, if you're only rolling it once, you can't roll a 2 and a 3 together. So these are going to be mutually exclusive. About rolling an even number and a multiple of 3. Well, if I roll one roll, think about even numbers. 2, 4, 6 would come on the die. What about a multiple of 3? Well, even numbers are 2, 4, and 6. Multiples of 3 are 3, 6, 9. We'll see how they both have something in common here. So one could happen, they could both happen, so not mutually exclusive. Example 4 talks about 37% of students take Spanish, about 15% take French. What is the probability that a student chosen at random is taking Spanish or French? Now, are these events mutually exclusive? One could argue that they're probably not, but because they don't give me a percentage of how many are taking both, we're going to assume that they are. So our probability of Spanish or French is the probability of Spanish plus the probability of French. Okay, so what does that mean? That means 0.37 plus 0.15 for a grand total of 0.52. So 52% take either Spanish or French. Problem 5 talks about finding the probability of that picture on the right there. Suppose you reach into a dish and select a token at random. What is the probability that the token is round or green? Or means to add. So what's the probability of round? Well, if you count the round, there's what, 5? Out of how many total? 9. Plus, well, let's find the probability of green now. So there's 3 green out of 9, but I can't add those up because they're not mutually exclusive. There are round and green ones. So I'm going to subtract the round ones that are also green. So the overlap there is 2 over 9. That ends up giving me 6 over 9, which reduces to 2/3. 6 over 9 is what they want.